The purpose of this video is to talk about the improvements that Josef Prusa has made to the i3 MK2. He's calling it the MK2S. But before we get into that, I want to show you some amazing 3D prints. I already did the filming of this video last night. I was complete. I was satisfied with it. And then ThinkMaking followed me on Instagram. And I was already subscribed to ThinkMaking, but I looked through his pictures and I found one where he had this copper filament printed parts, and he aged them using some easily available chemicals. So I want to give you a quick show that you can create this too. Now you got to keep in mind that the copper filament is it contains metal and it is abrasive on brass nozzle. So you have a brass nozzle that is a softer metal. It will chew through it and wear it out. So you may want to consider getting a hardened steel nozzle or even a ruby nozzle that they have.
So back to the review. This is Formfutura's classic copper filament from their Metal Fill series. That's right, copper. This filament has actual copper fused to it. And not only that, it also has one of the highest metal to plastic ratios in the market, of over 80% copper and only 20% PLA. What that means is that you'll end up with a print that looks just like real copper. Yet, to achieve this look, some post-processing must be done. Let's see how this filament prints. As always, I printed my 3 usual test designs: a calibration cube, a Marvin, and a 3D benchy. Using an E3D V6 at a 0.2 layer height, I found 195 degrees to be a great printing temperature. The aged look in the skull and the griffin looks so good, it's like if they were meant to be printed and post-processed like this. But I still want to tumble and polish his prints, and this is ThinkMaking, so instead of buying a rotary tumbler, I will design one myself, 3D print it, and upload the designs for all of you to use. I already bought the motor and the controller, but it will take a month to get to 100.
That's awesome. You know, so this guy is right up my alley. He is a maker. I'm a maker. Rather than buying a tumbler, he's going to build a tumbler. So if you like what you saw, make sure you stop over to ThinkMaking, subscribe to his channel, give him a comment, like his video. Yeah, you can create this too. Alright, so this here is by Caro. You can see here he spent over 200 hours preparing this. So I want you to watch this video. I don't want you to. The purpose of this is to bring this to your attention. So he has all the parts that he printed at his desk, at his workbench, and he is assembling this engine. It's down to the camshaft, the rollers, the pistons, the rocker arms, the head gasket, not the gaskets, the heads. I don't think he printed gaskets. The flywheel. He's got everything connected, and with a motor that would be where the starter motor would be attached to. He's got an electric motor that runs it. Alright, so just want to give you a flavor of what he's going through. So he has all these screws. He assembles every part. Like he said, it's over 200 hours. And he's putting in the rocker arms right now. So then I just want to jump ahead and show you. He has it mounted. And it's running. There you go. That's where the starter motor would be attached to the flywheel. So that's some insane stuff. So I give him a lot of credit. You see he's got 345,000 views, and there's a reason why. He's got a lot of detail. So yes, you too can print this. You just need to either build a 3D printer or purchase one. So what I did is I purchased one from Prusa Research, created by Josef Prusa, and I'm waiting for it to be received probably the first week of April. So the whole purpose of the RepRap, which is replicating rapid prototyping, the community just works together. This is an open source concept. Anybody can contribute to the Prusa printer. Improvements are always being made by either the community or by the team of employees or by Josef Prusa himself. He has the manual that describes how to put it together, but the manual has just changed. And I want to show you the manual for the i3 MK2. Here's Joseph, and where he likes to be called Joe. So here's his one of the rooms that he has where all the printers are printing the parts. This is a description of the printer itself. You have the x-axis and the y-axis. You got the z-axis here, which is 2 motors that lift this in combination. All right, so this is what I'm going to receive. I'm going to receive a kit. So all these parts are going to be included. You know, I asked for the filament. So in the kit, he goes through, okay, this is the steps that you have to build. So I have to go through all of this. What I've been reading is that the advantage of building the kit is you immediately become familiar with what it is, what the printer is. Instead of just getting it pre-built and starting to use it, you have an appreciation for what's gone into building it, and you become very familiar with every part of it. So if you have a problem, you could talk about it with people on a forum, and you'll immediately have an understanding when they give you feedback that it could be this problem or check this. So the filaments can be purchased in many different materials. You know, you got ABS, PLA, PET, HIPS. I didn't know you could print in polypropylene. You have nylon and flex, and you also have carbon fiber. Anything other than PLA and ABS and PETG, those items will be rather harsh on the brass extruder nozzle. So you may have to purchase a hardened nozzle. They sell hardened steel nozzles, like around $30. You can even get a ruby nozzle, ruby gemstone nozzle. So the idea there is that it's a really good conductor of heat. So it will still yield as good a results as what a brass nozzle does as far as temperature for the extrusion. But it is apparently a very tough material and is highly resistant to being worn out. It would be equivalent to using a diamond for cutting. You can almost look at it like that. It's not quite as strong as a diamond, but that's comparing a diamond to a steel knife for cutting. One will wear out quicker than the other. So the i3 MK2S is the successor to the original Prusa i3 MK2. It has a couple small hardware tweaks. That's what they're discussing here. Okay, so it tells you how to identify the differences. Here you go. Here's one of the main differences. The X and Y axis, or this is for the Y axis. Instead of using zip ties to hold on the bearing to the plate, they're using U-bracket. So this U-bracket will be used with two nylon lock nuts, it looks like, to hold it in place. Okay, so you have Y-axis assembly. You have connection of the bearings to the Y-axis. You can see here they're using the U-bolts along with the nuts. All right, so this is one other thing that we saw commented on somebody else's video. I forget whose video it was. I'll have to pull that up. But here you have a mention of the plate orientation. Because one of the videos showed that the plate was oriented upside down. You know, he had the plate oriented correctly. He went to do something. He flipped it over, forgot that he flipped it over, continued to perform the assembly of the heater bed to this plate, and he had a problem. He discussed it with Prusa Research. They got back to him and said, you did not have the plate on correctly. So this step here is clearly showing that there is a registration mark that you can use to identify the proper orientation of the plate prior to assembling the heated plate to this mounting plate. So just to show you the printer, this is the printer that I ordered. It's the i3 MK2. This one here. You can buy it in two different ways. Now you have to be aware when you're shipping to the US, if you exceed $800, then you are charged a import tax. I don't know. I don't understand the significance of the import tax. Even if it is called an import tax, I'm not sure. But if you purchase, and so purchasing this as a assembled unit costs $899. Think. But if you purchase it as a kit, it's $699 plus shipping was $77. So it ends up costing $780, which is under that $800 limit for your charged an import tax. So that's one of the reasons why the kit is an option, and it's actually a better option if you are willing to invest the time in assembly. I'm reading that there's assembly times anywhere from 7 hours up to 3 days for assembly. And it's not 72 hours of straight assembly. It's usually they invest 6 or 8 hours a day over the course of 3 days or 2.5 days, and it ends up coming out to maybe 15 to 20 hours of effort. So on average, I'm reading that it's about 7 to 12 hours. The fastest I read was 7 hours for assembly. And I think that person who assembled it in 7 hours, that was their second printer that they assembled. Yeah, this is cool. See if we can zoom in. I see everybody ordered printers. I'm down around this area here. Alright, so we got somebody in Woodstown. See if we got anybody in Wildwood. Wildwood Crest. They're replacing Wildwood. Somebody in Wildwood has one. Other people in Jersey. So we already talked about Woodstown. Next closest is Mantua, so that's just up the road for me. And of course, there's a ton here. So yeah, so it's cool. You can see how many printers have infiltrated the US, these i3 printers. So here's some of the models. You know, these are out there available in Thingiverse, or other people just created them and printed them and shared them with Prusa Research here to show on this. So you got the castle. I see this printed a lot. Of course, Groot is a favorite. Baby Groot. Lego Batman. Autonomous robot. Check that out. You'll see a lot of printers do this, where they'll make, and I'm calling the community, the members of the community, printers, because they're known as. They're printing this Benchy, this little boat there. This is cool. I mean, look at the size of this. This looks like it's about 4, 5 feet, maybe. You know, Eiffel Tower printed out 53 printed parts. You know, look at this. Decorations. You know, this is crazy. This is stuff that you see in like a Pier 1 or a Hobby Lobby. These are things that you can now create yourself. You know, I'm even considering using stuff like this to create sconces. Have a wall sconce, but replace the globe for the sconce with some type of print. Would just look amazing. You know, lightsaber. Look at this hilt right there. That's crazy. There's the parts. You know, you got assembly, and then you got finishing work. Tom's approach to helping everybody understand 3D printing, it's really an unbiased approach. From what I can tell, he presents the information. He lets you decide. He gives you all the facts. Here's a simple tutorial on trying to understand what slicing is. I don't understand what slicing is. I don't have a printer yet. I have not gone through this process. I have never used a 3D printer. I have only gone through and watched some videos. So let's watch this video. Let's see if we can get an understanding of what a slicer does.
I'm Tom, and today I'm going to show you how to configure and use Slicer. So let's say you have your 3D printer all set up and ready for its first print. The last thing you'll need to do is to set up a Slicer, which is a piece of software that turns your 3D design files into G-code that the printer reads to actually print the object.
Alright, so there you go. So that is the definition of Slicer. Slicer will take the 3D model and it will convert it into G-code. That's the same thing as taking a 3D model or artwork that you do in some specialized 3D software, and then you have to put it through tooling or like a CNC to generate a G-code that the CNC will understand, to move the router around to cut out the different pieces. So the G-code on the CNC is to control the router to remove stuff. The G-code for a 3D printer is to move the extruder around to add material. So a 3D printer adds material, layer by layer.
Now, there's a couple of different slices available that do that for you. For example, Cura from the guys that make the Ultimaker, or Kiss Slicer, or probably the most popular one, which is simply called Slicer, with a free for an E. It's free, and when you set it up properly, you're going to get really nice prints from it. So let's get started. Actually measure your filament and then use that value. But keep in mind that that's only going to work in any way if you have calibrated your extruder.
I jumped ahead here. He's got some print settings here. So when you're defining your print, you need to make a decision what your layer height is going to be. And based on your layer height, there's some other parameters that you'll set, and it will help determine what the G-code is going to look like. So let's say you're doing an extruded object to create a cookie cutter. it's probably just going to be able to run around and do that pattern over and over and over again, adding to it layer by layer until it's done. Let's say you're doing a sphere. You want to do a solid sphere. Well, that solid sphere is probably going to need to be not solid, not hollow, but an in-between. And you can use what's a fill pattern and what's called an infill. That'll help maintain the rigidity of the object that you're printing. So in this case, honeycomb is selected, but there's different choices. So I'm going to let Tom play Tom's video in this section, and then hopefully we can jump ahead to see the result of Slicer and what it does for you.
First one is the layer height. The lower you set that one, the finer your layers are going to come out. Good values are 0.2 to 0.3 millimeters. The perimeters tell Slicer how thick the part's solid shell should be on each layer. And the solid layers tell it how many layers it should completely fill on the top and bottom surfaces of your part. Next up, infill, which determines the ratio of material to air inside the part's shell. By default, Slicer uses 0.4, which is 40% infill, and already on the high side. Normally you'd use 0.1 to 0.4, but you'd only go above 0.2 if you need to make a really tough part. The honeycomb style infill is theoretically very stiff and strong, but takes forever to print. Rectilinear is a bit more popular because it prints much faster and isn't that much weaker. Your call. Now, the rest of the settings on this page are special case settings that you use for specific parts. Especially brim is useful when your part wants to warp and peel off of the bed. Just set that to about 5 millimeters and watch the magic happen. When you're ready, hit export G-code, save the file, and you're done. Slicer will do its thing and spit out a G-code file which you can directly send to your printer.
So give this a thumb up. Make sure you stop over to Thomas's channel here. Give him a subscribe. He's pretty much the go-to person for a lot of the 3D printing stuff. So he has over 230 videos. A lot of them have to do with 3D printing. All right, here's Uncle Jesse. He's got some badass stuff here on his channel. You can see he's a cosplay, creator. He is a maker. This thing here, he did the Captain America shield. So here he's working on a Deadpool mask, and he did a 3D print of it, and he assembled it, and then finished it. So I'm going to give you a little tidbit. I'm not going to show you the whole thing.
Hey guys, in today's video I'm going to be showing how you can make your own 3D printed Deadpool mask.
Did you see how he did that? He showed you Iron Man, showed you Deadpool. So yes, he has quite a bit of stuff up here. Definitely cool how he printed this. I watched this when the video first came out. It was amazing work. So he printed this up into sections. See if he references any models. Yep, he's got the models referenced down here. He was using Matter Hacker's Black Pro PLA and the yellow PLA. And he even used wood filler. He attached the pieces. I forget how he attached it, but then he used wood filler to fill it in. Some people use Bondo on this stuff. I'm not sure how compatible it would be with PLA. But he goes through and he does the finishing. Definitely give his video a look on how he did this 3D printing, because he's a master at his craft. So here he's got a printing of the Black Panther mask. He came up with it here. Then he goes through a finishing process. So he goes through and
Are finished. Let's take them off. Gonna get these out of here and get them cleaned up. Look at those supports. Man, this is why, you see that? This is why I love Simplify 3D. Those supports break off so easily. Most of them.
Alright, so this is something that you have to understand when you're printing 3D. This part right here, if you were to print this without support, what would happen is as you begin to build up this layer, because it's doing it from the bottom up, so it's going to do the outside layer and it's going to start getting closer. As it gets around here, that would begin, right around here, it would begin to sag. So prints a support layer at the same time, which is wasted material, but it's necessary to keep it from drooping down and ruining the print, which would end up resulting in more wasted material because you would have to try it again over and over and over again. And so what he was using is Simplify 3D, which is a program that's available for purchase. The program apparently makes it easier to design these supports, and it makes the interface between the top of the support and the actual piece, the piece that is the good piece to the right, the support is in his left hand. It makes it easy for it to break away, meaning that there's only a little tiny bit that'll interface between the support and the main piece.
As the file or how the print's actually printed on my printer or what. Actually, I was able to just now
check that out. So that's cool. I mean, look, you can make your own Halloween costume crap now. Yeah, so Jesse, you did another good job on this one. So you're doing the Marvel community right here. So again, visit Uncle Jesse's channel and give him a subscribe and like his video. So the Rob Andrews here, he's got his YouTube channel. Make sure you stop over, subscribe, give him a little shout out here. He is putting together a 3030 during a live build. This is recorded towards the end of January. It's over a month old now. He is referencing this GitHub that I showed in my previous video. So if you don't know, GitHub is a repository for software or builds. This is all the information on it that I reviewed. I'm not going to go over this again. You can see my previous video. This is the build that he is performing now. So I'm going to give you a little, this is a 4-hour build. He is performing this upgrade on his i3 Mark II.
Yeah, I'm likely nude, definitely.
You can see this is the i3 Mark II right here, right? He's showing the top-down view. And then he's going to begin disassembly and assembly. So right now he's beginning the assembly of the Haribo edition.
They don't go like that?
And this is using 3030 extruded aluminum, which will be more rigid and should yield better print results, right? That's the idea.
Okay.
So if you're interested in doing this build, this assumes you already have the i3 Mark II, or perhaps you're building your own i3 Mark II. This is where you come. Watch this video. He's already done it. The bill of materials is complete on the GitHub site. It tells you exactly what you need to get. And you can see here, full credit has been given to JT K Tam for the original design of the Haribo. And this is part 1, so let's see if he's got a part 2 up. Okay, we got a part 3, we got a part 2 here. This is 2 hours and this is 3 hours. So altogether, he's got about 10 hours invested in this.
Get in the mode.
So he's continuing with the build. Installing the heat plate, now he's installing the Rambo board.
But
yep, now he's going through and doing the testing. Alright, so now he's up and running. Look, he's got his Haribo right there too. God, I love gummy bears. So he's printing a Batman.
come on, Batman.
Yeah, so you know what? Good job, Rob. Alright, so make sure you stop over to Rob Andrews' channel and subscribe. Alright, this next one I want to show you is Jimmy Shaw's Tidbits. He prints the lion, and I wanted to this is the lion that's out there. You can get access to it from Thingiverse. But here he's using the specialty PLA, which is a carbon fiber PLA. So carbon fiber PLA presumably will be stronger than regular PLA because it has carbon fiber in it. It's also going to wear out your brass nozzles more quickly. So this is the case where you're going to want to get a hardened nozzle if you're going to do this frequently. I have no idea the impact it's going to have on the nozzle. I know it's going to wear it out. I don't know how many hours of printing you can do, or how many miles of filament. I don't know, feet of filament that you have to go through, or how many pounds of filament before your nozzle starts showing wear. But you'll notice at some point that your prints, if you were to print the same thing at the beginning and then print the same thing 1,000 hours later in prints, you would notice a difference from what I'm reading. So that's why they're saying you get a hardened steel or like a ruby nozzle for printing material like this that's resistant to the excessive wear that it's going to impact the nozzle.
And I was even more surprised that I could actually shape it with a heat gun like, but wow.
So now you can see that's the sheen on it. You know, it's carbon fiber. I mean, this is badass stuff. This print came out really well, I think. So, Jimmy, you did a really good job with this carbon fiber. Give Jimmy's channel here some love. Go over there, you know, subscribe, give him a like, tell him I sent you. Anyway, thanks for watching my video. I hope you found it helpful or enlightening and maybe inspire you to learn more about 3D printing or to pass this information on to somebody who you know would be interested in 3D printing. Let me know if you knew about 3D printing or if you learned anything from this. Give me an idea of maybe what you would like me to cover next. Keep in mind, I don't have a 3D printer yet. I'm trying to learn and understand. I do want to develop a workflow. I'm sure that there's plenty of workflows out there, but me being a software engineer, I find it necessary to break the steps down from a process standpoint. Show that, okay, you have a model, you want to take that model and somehow print it up into 3D. Can the model be printed in one piece, or does it have to be broken down into separate pieces? How do you do that? Piece is going to be one that's going to be printed and will sag as you're printing. You'll have to develop supports if it's something where you need rafts, which I don't understand what rafts are, but we have to learn about them. These are all these things that I'm going to bring up in future videos. Really want to learn about this stuff and understand it prior to receiving a printer, so that when I receive the printer, I can get rocking and rolling. So thanks for watching the video. Give it a thumbs up if you liked it, give it a thumbs down if you didn't, and most importantly, make sure you subscribe. And be sure to check out my other 2 3D printing videos, where you can see I talk about different topics for upgrades and things like kinetic art and different types of art. Thanks again.